right, Algebra 2, we're back. We're going to be going over some parametric equations stuff. There'll be two problems where you'll be asked to define the parametric equation itself and find the value when to find x and y when t is a certain value. And then there are two where you're just asked to graph the parametric equation. So hopefully if I don't make any sudden moves, I can get through this without hacking up a lung. So let's give it a shot. So in the first question we are asked, let's see, we are given a couple data points here. So when time equals, so when time equals 0, then, let's see, x equals -1, and y equals 6. When time equals 1, then x equals 1 and y equals 7. And when time equals 2, then let's see, x equals -9 and y equals 14. So here's our t value, our x value, and our y value. Not a v, a y. Okay, so we're going to make ordered pairs in terms of t and x and ordered pairs in terms of t and y and come up with an equation explicitly x as a function of t and y as a function of t. So let's make those ordered pairs. So when t is 0, x is -1. So we have the pair, let's do t and x. So we have the ordered pair 0, -1, the ordered pair 1, 1, and the ordered pair 2, -9. So let's put this, so we get, let's see, I'm assuming this is going to be a quadratic and not a linear because this difference here is 2 and this difference is not 2. That's what, it's going to be -10. So we can assume this is going to be a quadratic, so we'll write it as x as a function of t equals a times t squared plus b times t plus c. So let's replace our x. So we have an output of -1. X of t is x of 0 is -1. So we're going to have -1 here equals a times 0 squared plus b times 0 plus c. Second pair, 1 was the result of 1, so we get 1 equals a times 1 squared plus b times 1 plus c. And for our third pair, we get -9 was the result of a times 2 squared plus b times 2 plus c. And hopefully by now you can just plug these coefficients into your into that blue bit calculator. There is a way to solve this by hand. It's a pre-calculus skill and not a particularly useful one, so we're just going to use machines for this, and we're going to come up with a equals -6, b equals 8, and c equals -1. And so what that means, we'll plug that back into our original equation here, is that x of t, I'm going to run out of room here. Let's write it down here. So x as a function of t equals, so a is -6, it'd be -6t squared plus b is 8, so it'd be 8t minus 1. This marker's not behaving itself very well. And there's our x equation. And let me erase some of this to find our y equation here. It's going to be the same thing. And instead of x of t, we're talking about y as a function of t here. Okay, so let's write our data points. So when t equals 0, so we'll do t and y. When t is 0, y is -6, so we get positive 6. When t is 1, y is 7. And when t is 2, y is 14. So same idea. Let's check. So the difference here is 1, difference here is 7, so it's not linear. Let's just write this as a quadratic. So we get, let's see, 6 is the result of a times 0 squared plus b times 0 plus c. 7 is the result of a times 1 squared plus b times 1 plus c. And 14 is the result of a times 2 squared plus b times 2 plus c. And we'll punch all that in and find out that a ends up equaling 3, b ends up equaling -2, and c ends up equaling 6. So we get y as a function of t equals 3t squared minus 2t plus 6. And what are we asked to find? We're asked to find what happens when t equals 3. So now all we have to do is punch in 3 here to find our x coordinate and 3 here to find our y coordinate. So it'd be x of 3, so it'd be 6 times 3 squared. 3 squared is 9 times -6, it'd be -54. So x would equal -54 plus 8 times 3 is 24 minus 1. So -54 plus 24 is going to be -30. Minus 1 is going to be -31. And then our y value is going to be, let's see, t squared. So it'd be 3 squared is 9 times 3 is 27. Minus 2 times 3 is 6. And then plus 6 will just go away. So that equals 27. So when t equals 3, we have an x value of -31 and a y value of 27. And there's problem 1. All right, problem 2. Okay, so we have the data points. We've got when t equals 0, we have the points -4, 2. When t equals 1, we're at 4, 3. And when t equals 2, we get 12, 6. Okay, so this is our t value, this is our x value, and this is our y value. Okay. Let's check and see if either one of these are linear. Let's see, the difference here is 8, and the difference here is 8. So we're actually going to get a linear function here. So I can actually take a little bit of a shortcut here. So let's do our x first. So x as a function of t. Now we could go a times t squared plus b times t plus c if we didn't realize that this was linear. But we don't have to do that. We can do it the linear form, just pick 2 since we know it's linear. So let's just go a times t plus b. So let's just pick these. Let's just pick these first 2. So -4 was the result of plugging in 0, so equals a times 0 plus b. And also we get 4 as the result of plugging 1 in, so 4 equals a times 1 plus b. And when we plug that in, we get x as a function of t. Let's just do that down here. X of t equals 8t minus 4. So we get an a value of 8 and a b value of -4. So that was easier than quadratics. How fun. All right, now let's do our y as a function of t. So when we plug in, let's see, this is going to be our t value and our y value. Let's get our pairs here. So when t is 0, y is 2. When t is 1, y is 3. And when t is 2, y is 6. And it looks like this is not linear. This difference here is 1, and this difference here is 3. So we're dealing with a quadratic. So our general form is going to be y as a function of t equals a times t squared plus b times t plus c. Let's just plug things in. So 2 is going to be the result of a times 0 squared plus b times 0 plus c. 3 is going to be the result of plugging 1 in. So 3 equals a times plug 1 in for t, so 1 squared plus b times 1 plus c. And then 6 as a result of plugging 2 in. 6 equals a times 2 squared plus b times 2 plus c. And we'll use our technology to discover that a ends up being 1, b ends up being 0, and c ends up being 2. So y as a function of t ends up being 1x squared, or t squared. Plus 0t, we can just leave that out, and then plus 2. Okay, and we're asked to find what happens when t equals 10. So let me make some room for myself here. When t equals 10. So to get our x value, we're going to plug 10 in for t here. So x would be 8 times 10 is 80. Minus 4 would be 76. And then y, we're just going to plug in 10 for t here. 10 squared is 100, plus 2 is 102. So when time equals 10, we get the ordered pair 76, 102. And we're done. That's how that goes. Not a single cough yet. This is fantastic. I didn't expect this. Hopefully I didn't jinx myself. All right, now, in the second part, we're just asked to graph these equations. Let's check and see how much time we've got. Oh, we're good. Okay. Okay, so in this case, we are given that y as a function of t is 2t minus 1. And x as a function of t equals square root of t. I have to graph this from 2 to 6. So let's make a little table here. So we know we want to catch 2. We want to catch time equals 2. We know we want to catch time equals 6. And we'll get a couple points in between. I'm thinking 4 is a good candidate because 4 is a perfect square. That'll work well here. So let's do when t equals 2. Let's see. Our x coordinate is going to be the square root of 2. So not much you can do with that. And our y coordinate is going to be 2 times 2 is 4 minus 1 is 3. And let's just do 4 and 6. So t equals 4. That result is going to be the square root of 4 as our x value, or 2. And then, let's see, 4 times 2 is 8, minus 1 is 7. And let's get to t equals 6. Okay, square root of 6, that doesn't really break down, so it's just going to be root 6. And 6 times 2 is 8, minus 1 is, 6 times 2 is 8. 6 times 2 is 12, minus 1 is 11. Okay, so we've got 3 data points here. Three points that we're going to plot on our graph here. And we'll kind of adjust our scaling accordingly. It looks like the biggest y value we have is 11. Looks like the biggest x value we have is the square root of 6, which is, well, the square root of 10, the square root of 9 is 3. And the square root of 4 is 2, so it's going to be between 2 and 3. So we'll just kind of make it, well, it looks like this is going to dictate how big our graph is if we're going to keep it even there. So let's just go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and on up here 2, 3, 4, 5, 6, 7, 8, 9, 10. And I didn't actually have to draw any negatives there because they're all positive, but that's fine. So let's plot our points. The square root of 2 is about 1.414. So that's our x value, like 1.4 something, and then we go up to 3. Then when time equals 4, we have 2, 7. So 1, 2, and then 1, 2, 3, 4, 5, 6, 7. So like about right here. And then we have square root of 6, which is somewhere between 2 and 3. So right about in here. And then we're going to go up to 11. So it's looking something like this. And since we caught these points, there's going to be a solid dot here. So it's going to look kind of like this. And we know that we're going in this direction. So that's going to be our graph from 2 to 6. All right, last one. Okay, we have y as a function of t equals, where are we at? T plus 1 over t minus 1. And x as a function of t equals t squared minus 4. And we're taking that from 2 to 4. From 2 to 4. All right, so let's make a table. I'm pretty sure we can be okay just catching 2, 3, and 4. So when t equals 2, we get the ordered pair. Let's see, x would be 2 squared minus 4. That'd be 0. 2 squared is 4 minus 4 is 0. And then our y value would be 2 plus 1, which is 3, over 2 minus 1, which is 1. So it's just going to be 3. Did I do that right? 3 over 1 is 3. And then when t equals 3, we're going to plug 3 into both these equations to get our x coordinate. It'd be 3 squared is 9, minus 4 is 5. And then our y coordinate is going to be 3 plus 1, which is 4, over 3 minus 1, which is 2. So 4 over 2 is 2. And then when t equals 4, we get our x value is going to be 4 squared is 16, minus 4 is 12. And then 4 plus 1 is 5. 4 minus 1 is 3, so it'd be 5/3. Is that right? Yeah. Okay, so here are our data points. Let's draw ourselves a graph here. So our biggest x value is 12, our biggest y value is 3. So let's just kind of make a, and they're all positive. Let's just go ahead and make a graph kind of like this. It would extend down like that, but let's go, let's see, x would be 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And we don't have to go that high with our y. Let's just go 1, 2, 3, 4, something like that. So our first point, we're going to plot 0, 3. So it's going to be right around here. Next point, we're going to plot 5, 2. So 1, 2, 3, 4, 5, and up 2. And our last point, we're going to plot 12 and 5/3, which is about a little over 1.5. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and about 1 and, well, it's 1 2/3. So we'll just kind of go like this and connect the dots. And we know that since we're going, we started at this point here, we're ending here, we're going in this direction. And there's your graph. Hopefully this helps. See you next time.